Hello everyone. In today's video, I will show you the functionality of the feature called Analyze Data Volume in Calculations in SAP IBP and how we can leverage this application's functionality to identify different bottlenecks in terms of performance or runtime that we face while we load multiple planning view templates or favorites that contains multiple key figures, multiple attribute combinations, as well as multiple value based filters or any other criteria, which in a way creates a longer runtime for loading a planning view template or even a favorites, and how we can leverage this application to get all the detailed information and look and identify such probable bottlenecks in order to take corrective action with an end result to improve the performance and the runtime and obviously the user experience of a excel based planning view or the favorites. So under model configuration you will find this app called Analyze Data Volume in Calculations. Now, how to generate reports based on what, this is what I'm going to show you. So for example, I have a favorite which I have saved, and inside that favorite I have a view called vendor view. This view has certain key figures. This view is loaded with certain levels of attribute combinations and at a calendar week level. So we will try to see how the data volume numbers are coming, and we will also try to see if there is any scope for improvement for the performance runtime of this template by looking into the report that the analyzed data volume application will generate for us. So, to start off with, so here when we come to this app, we will need to create a report for a particular planning view. In order to do that, I will go to create, select the appropriate planning area, and once I select in the next drop down, I will get the list of all favorites and templates that are assigned against my user ID. Since for this purpose of this demo, I have created a favorite template called data volume analysis. And inside this data volume analysis, I have a view called vendor view. So that is what we will be focusing on in today's demo. So here I select the vendor view and I plan to run the report based on my user ID, but here we have the option to run a report based on anyone's user ID provided we have the proper authorization to do so. So once we have filled this required information, we click create. The moment we click create, here we could see that the report status is running. So what happens here is the moment we create the report, the system basically runs all the required calculations and steps of the vendor view as if it is being loaded in the Excel front end. And it takes into account not only the key figure calculation that are being displayed, but also all other interim helpers, attribute transformation, filter blocking, and even calculation sharing node details so that it can give us a detailed information of how much data records are coming at each level, if there is any filtering block, so on and so forth. So it takes a couple of seconds. So if I click here, you will see that the status is now changed to success. That means the report has been generated. Now it's time to go and check the report. So if I go into the report, at the header section of the report, what I can see is in that planning view, what are the key figures that are being used. Also, what I can see is what are the at which these key figures are being viewed or edited in this particular data view. So this gives me an overall idea. Now in this section, you will see that we will get a list of all the key figures and their calculations at request levels, and in each request level, what are the different input calculations that are getting involved. So there are primarily two ways to view this. One is group by key figures at request level, and the other is ungroup and view individual key figures like this. Although personally I like the other view because it gives me a more holistic pictures of how the calculation at each key figure is happening, what are the dependencies of the interim calculations, and what are the dependencies that this key figure have on any other key figure for getting the desired output. So if you see here, first we can see that there is a filtering block at the period ID 4, which is the calendar week level. So here it says that the filter block is yes, and wherever based on this filter blocks the calculations are getting impacted, in all those level you will also see that the filtering block is also displayed. So that means in all this calculation at this particular level, this filter block is getting used or it is having an impact on the calculation. So if you focus on this first key figure, let's say this dependent demand ds key figure, the downstream key figure, in order to generate the numbers of this key figure at a request level, we can see what are the different input level calculations that are getting involved. For example, the dependent demand ds at the base planning level, then the UM conversion, and post conversion the prod lock to UM2 levels. So in order to get the result at this request level, these are the three levels of calculations that is happening. And from here we can see at each level what is the number of data records. And this data record is getting generated in runtime based on whatever ad hoc filters that exist in that template or favorite at that point of time. Also, one thing that we need to understand is this column called calculation node share. This is a very important column. Why? I will explain that. So if you see calculation node share, and if you click onto this, you will see that in order to generate the calculation of dependent demand DS at request level, this three key figure level calculation has to happen simultaneously and parallel in order to get this desired number at the request level. So at each key figures planning level, it also shows me what are the dependent calculation sharing nodes. So by looking into this, we can basically get an understanding that among the key figures that we are using in the planning view, which are the key figures that are supposed to take the most time and that are supposed to take the lowest amount of time. Now, how to identify that? Although there are no thumb rule to that, one thing that we need to understand is if a calculated key figure, we are using a calculated key figure on a particular data set, if that calculation is a simple arithmetical calculation, then the calculation output or the results is relatively much faster and takes very less time. Whereas in key figures, if I am having, let's say, L codes or I am using some simplified functionality like cumulative aggregation or coverage, so those kind of calculation are not straightforward, and in the same data set to calculate it takes considerably high amount of time to get the results. And furthermore, to add to the complexity is the output of a calculated result. If that output is used in multiple key figures as the input, the more the number of inputs, the more performance intensive the calculation is. So let's see how we can understand that. So if you see here in this simple key figure, if I look at dependent demand or transport or any other key figure, the moment I come to this key figure, I could straight away see that this key figure is comparatively more performance intensive than any of the other key figures in this planning view. How? Primarily, if you see here, the number of calculation levels used to derive the numbers at this key figures request level is higher than any of its other key figures. So the number of levels that will be involved is directly proportional to your increment in runtime. Also, I could see that there are filter blocks, multiple filter blocks here, whereas in other key figure calculation, you will see there are single filter blocks, whereas in this calculation, there are multiple filter blocks, as well as the node sharing are also higher since the number of input level calculations are high. So this is how we can take a look into different key figure calculations and identify what could be the probable key figure that cause the most performance. So now if you see here, based on all these key figures that we have in the detailed runtime report, I could see that at a base version at a time of calendar weekly level, my query runtime is 195 milliseconds and records of output data set is 49140. Now, assume that this key figure is the key figure that is creating the most problem. So, how will we understand that this is the most problematic or the most time taking key figure? So, for that purpose, what I will do is I will go back to the view wherein this is the key figure Z transport DS that we are talking about, and I will remove this key figure from the favorites. So I will go to the edit view and I will simply remove this key figure. Click OK. And now I have removed the key figure. One important thing is once I remove, I need to make sure if it is a template or a favorite, I need to go and update that particular template or favorite, or else that application won't be able to understand that I have removed a key figure. Now, with this saved, let's go back to the data view. Now, before removing the key figure, we have seen what is the runtime, query runtime, and what is the output data set. Now, with that done, what we will do is we will take a new volume report run and see if there are any difference or not. So I will select this one and just click copy. And just to ensure that I am on the correct one, I will select the vendor view and I will click create. The report is now complete with the status success. Let's see. First thing you see that here the correct numbers of key figures are now updated because I have removed the Z transport DS key figure. And based on that, let's see what are the runtime or the data output set numbers and what are the changes compared to the previous report when that key figure existed. So irrespective of the fact what happens, the existing key figures will have the same data record, time series records and calculations. Now, when I come here in this detailed report, we can see that although the same data record exists, my query runtime has now come down to 91 milliseconds. That means close to a 50% improvement in runtime. If you see in the other report, with that key figure, I was having 195 milliseconds. And since I removed these key figures, Z transport DS, the query runtime came down to 91 ms. Now, this is how we can check key figures that takes the highest query runtime, and if this problem are really a problem that is creating a slowness in the planning view or favorites, we can take a look into this bottleneck key figures, see if we can further optimize our calculations, or even split this calculation into two separate key figures with more simple arithmetic calculations, so that the planning views can load faster and we have a smooth web XLUI experience. So this is why what I intended to cover on this video. I hope you will find this information useful, and please don't hesitate to share or send your comments if you like this video and find it useful. Thank you.